Hello, today we'll be talking about computer architecture. The first question is, how does the CPU fetch, decode, and execute instruction? The process by which the CPU fetches, decodes, and executes instruction is known as the instruction cycle, and it typically consists of the following stages. These are the stages. Fetch. The CPU uses the program counter to keep track of the address of the next instruction to be executed. The instruction at the address is fetched from the memory and brought into the CPU. This is done through the memory bus. After fetching the instruction, the CPU increments the program counter to point the next instruction in the memory. The second stage. Decode. The fetch instruction is then sent to the instruction register. The CPU decodes the instruction to determine what operation needs to be performed. This involves interpreting the code and other operands associated with the instructions. The control unit of the CPU interprets the instruction and generates the necessary control signals to execute. The last stage, execute. The CPU executes the instruction using the appropriate functional units, such as the arithmetic logic unit. This may involve performing calculations, moving data between registers, reading from or writing to the memory, or interacting with input or output devices. The instruction involves storing a result. It typically writes the result back to a register or memory location. This cycle, in summary, this cycle is fundamental to how CPUs operate and is essential for executing programs on computers. And we have another question that says, why does the data path cycle have a huge impact on the performance of a CPU? The data path cycle significantly impacts CPU performance because it determines how efficiently the CPU can execute instructions and manipulate data. A shorter data path cycle allows for faster processing of instructions, reducing the time taken for each operation. This efficiency is crucial as it minimizes idle time for internal components, enabling the CPU to execute more instructions in a given time frame. So, as you can see, the image there is the CPU, the life cycle of the CPU. And the life cycle of the CPU, the first one talks about instruction execution time. The data path cycle defines the time required to complete each instruction. In a single cycle data path, all instructions must complete in one cycle, which can lead to the inefficiencies of some instructions take longer than others. A multi-cycle data path allows different instructions to take varying amount of time, optimizing the execution. The second one is resource utilization. A well-designed data path can share resources like the ALUs and the registers across multiple instructions, reducing hardware cost and complexity. In a multi-cycle design, functional units can be reused, which enhances resources utilization and minimizes the need for duplication components. The third one is pipelining opportunities. Shorter data path cycles facilitate pipelining where multiple instruction phases, to bracket the fetch, decode, and execute, occur simultaneously. This overlapping of instruction execution significantly increases throughput and overall CPU performance. So, in all what the computer architecture is talking about, in summary, the data path cycle is fundamental to the CPU performance as it affects execution time, resource utilization, pipelining capabilities, critical path length, and overall efficiency in processing instructions. Thank you very much for listening to Computer Architecture.